Hi, welcome back to the Shiko SAT review series. And we are still in this topic, linear equations. Like I mentioned before, linear equation takes a big portion of the SAT and ACT exams. So in this unit, under the linear equation, we're going to talk about another things. We're going to talk about how to scatter plot and the linear equation fit. Okay, what's that mean? And what will be the strategies when we try to solve this kind of the problems here. Okay, so now let me go to the worksheets and let's take a look at what type of the problem, and also we'll get a brief review. What is the scatter plot and the linear equations here. Okay, so first let me go to the whiteboard so we can have a very brief lecture about the scatter plot here. Okay, so what is the scatter plot? Okay, so the scatter plot is what is like we have a paired the data. Okay, so that means we could have X and Y, and we kind of suspect, X and Y maybe have some type of the relation. So we will collect the data and want to plot it. So for examples here, right? So let's try to take a look at the examples here. What is the scatter plot and what is we try to do with the linear equations here. So let's take a look here. So X and Y here, we say it's a paired data. So if this example I say, hey, I want to see the X is the numbers of the hours you studied for the exam, and Y is your score or your grade, right? So it's your grade or your score for the exams here. So like here is the 1 hour, 2 hours, 3 hours, 4 hours, 5 hours, 6 hours, something. And then you got a 50, 60, 70, 80, 90, and hundreds here. So like for example, I would take the data from the students. So I will ask maybe 20 students, I say, hey, how many hours you study? And then I can check to see what is the grade, right? So for example, if I have something like this, so if I plot it, maybe I will get some plot like this here, right? So as you can see, those are the students' paired data regarding to the number of hours and the studies here, right? Number of the study and the score you're going to get for the exams here. So that's what we mean the scatter plot. So we see they kind of have a relation. Seems that you study more, you get a higher grade. And so what is the regression line of the fit here? So the regression line of the fit basically say, hey, I want to see I see there is a relations here. So I want to find a line to best fit all those points here. So this is what I call the regression line of the fit. So the purpose for this regression line of the fit here, and I'm going to use this line to estimate what the results, right? So basically, this is a regression line of the fit. So basically, I can use to estimate or the forecast, right? So predict. Okay, so I can do those things. So what's that mean? So that means like if I have a based on my previous data, right? So like for the next exam, you say, hey, I'm going to study 5 hours for the exam. So what is the grade I'm going to expect? So basically that's why you say, okay, you want to study the 5 hours exam. So based on this linear regression line of the fit, and then you estimate, oh, I probably can get an 85 or 90 here, okay? So here, from the SAT point, right? how to find this regression line of the fit. Because the regression line, find the regression line of the fit really is like in the college level class, they have a formula help you to do it. But from SAT point, basically we just look, we find this relation. So sometimes you will plot like a couple points, you will use a couple points close to the line and try to estimate this line. Or, so this is one type of the problems here from the SAT. They kind of want you to estimate the lines here. So they're not going to be very it's not like you need to apply the certain formula. Like I said, how to find a regression line correctly, it will be in the college level course. Of course, this is SAT. So we just basically use the data to estimate. And I'm going to show you how to do that. Right, so how to kind of to see what is the line looks like. And then the second kind of the problem, they will give the line. So the regression line will be given. So the problem will say, hey, this regression line is what? And then they want to find the estimated value. That's it. Okay, so they will give you, they say, hey, maybe this one's here. They will say this regression line is y is equal to the 10x plus 50, something like that, right? So they will give you the line, then they want you to estimate here, okay? That's it. Okay, so now let's take a look at the problem to see how can we use this concept, right? So this is kind of like a very useful, the applications, right? So you suspect some type of relation, then you try to use line to predict these relations here, all right? Okay, so now, and I'm going to go to my worksheets here. All right, so let's take a look at this worksheets here, right? So this one's here, they said, okay, let's take a look, right? All right, so the first problem is here. Let's highlight the things. So let's say the scatter plot show the company's ice cream sales, right? The ice cream sales is here. And is the D's, right? In dollars. And the high temperature T, and the T is here, right? So the temperature, in the Celsius in 12 different days here. So a line of the best fit of the data is given. So which of the following will be the equation for the line of the fit? Like we said, in order to, sometimes I always tell the student, you can just say, okay, the temperature is your X value and the sales is your Y values here, right? So then later you, instead of D, C, those things, right? So, okay, so now, like I said, now for this problem here, we have a scatter plot. I know the temperature will affect the ice cream sale. So in here, I want to see what is the line looks like. Like I said, those line is just an estimate, right? So what I'm going to do, I'm going to choose the line is pretty close to the coordinates here. So like in here, I'm choosing like maybe I will choose in this point, right? And I'm going to choose maybe this point because these two, they touch the coordinates kind of close, so I can estimate it here. So remember, right? So we say the slope here, right? So this is the one. Okay, so these 2 points I choose here, this is the y. So this is 12. And what is the y is here? It's kind of close to what? So I'm sorry, the 12 is, oh no, this one is not a good one to choose here. Okay, so I want to choose this one, 16 here is better here, right? Okay, so now for these points here, right? So this is the 16. Then what is the value here? Very close to 600, right? So this one's here is 22. What is the values? Pretty close to 800, right? So I have 2 points, so I can find the slope. So the slope will be y2 minus y1. So it's 800 minus 600 and the 22 minus 16. right? So 22 minus 16. So I will have like 200 over 6. So I close to what? I'm close to 33. So if you divide it by the 200 divided by 30 by 6 is close to the 33s here. Okay, so now you immediately know, okay, so the slope has to be 33. So you know this one is not going to work. This one is not going to work, right? Okay, so now the next thing here, you will say, which ones, right? So which one is like the 33t plus 300, or D is 33t plus 84. So in here, you can choose another point to try to estimate. So the way you estimate, you can say, okay, let's try to plug in the, the D. Okay, so it's equal to, let's try to do these numbers here, right? So it will be 33 times 12, okay? And then the plus 84 to see is this one is closer or not, right? So like if you do the 33 times 12 here, so 33 times 12, then plus 84, so it's 480. So it's 480. So as you can see in here, this point is pretty close to 500. So I know my answers here will be D. So if you do C's here, this will give you way bigger numbers, right? So that will not work. Okay, so that's it. All right, so let's take a look at the second part here. So the second part, this is another type of the problem like we talk about. Okay, so this one, let's say, the scatter plot above show the data collected on the length of and the width of the iris petals, right? So a line of best fit data is shown based on the line. So in here, right? So in here said, okay, this is the width and this is the length, right? So this is the length here. So they give you this equation. That's what is the second type of the problem we talk about. They will give you the regression line of the fit. And then they want you to estimate, they want you to what? They want you to predict length of the millimeters, right? So this one will be pretty easy. So I know the y is equal to 1.67x plus 2.21.1. So they want to have the petal is 19 millimeters, right? So the width of the petal is 19 millimeter. They want to find the length here. So okay, so what do you need to do here? You just plug in the 19 plus 21.1. So you will get like 52.83. So what is the answer? So answer is C here, right? So this is a pretty easy problem to do. Okay, so now let's take a look at the problem number 3 here. Okay, so the problem number 3 is here. They say the figure showing the relationship between the percent of the leaf litter mass remaining after decomposing for 3 years and the mean of the annual temperature in degrees in 18 forests, Canada's a line of the best fit. All right. So now they ask you, they say a particular forest in Canada whose data is not included in the figure had the mean annual temperature is -2. Based on the line of the best fit, which one is the closest to the predict to the leaf litter mass remaining in this particular forest? Right, for decompose for 3 years here. Okay, so in here, this is just the same things here. Even they did not tell us exactly what is the equation looks like, right? But now they say here, okay, so the problem here, we want to estimate if it's under the -2 degrees Celsius, then what will be the this is the mass remainings, right? So this is the mass remainings here, okay? So now let's take a look here. So now in here, this is 0, this is -5. So I know this point is -2.5, right? So that means, the -2 will just be a little bit off here. So let me see if you do like a -2 here, right? So then you use this point on the line to estimate. So what is here? According to the prediction line is what? It's 70, right? So that's what we say. Okay, this is the 70. That will be our answer. So that's another like the second type of the problem I mentioned in our lecture. They will give you the line and want to do the predictions here. Okay, so let's take a look here. This one's here, right? So this one's here. This is the minimum wages here. Okay, so this one is very similar, but it's a little bit tricky here. Okay, so the scatter plot above showing the federal mandate minimum wage for every 10 years between the 1940 and 2010. The line best fit in this equation is this one here. So what does this line fit predict about the increase in the minimum wage over the 70 years period? Okay, over the 70 years period here. And so a lot of the people here, right? So the people getting confused is like in here. Okay, so let's say, what is the meaning of that? So this is my given line. So essentially, people will say, okay, so well, it's every 10 years, right? So what's that mean? So here is the confusion part. This is for every 10 years between the 1940 and 2010. And then here, the x-axis here is the years since 1940s here. Okay, so now we said, they said, okay, so this is the linear regressions, right? So this is y is equal to 0.096x minus 0.488, right? Okay, so in here, let's take a look at the first one. They said we know so like we hope that everybody remember what is the slope mean? Slope means what? Every unit of x change, right? If it's positive, that's how much the y increase, right? Or if it's negative, that means how much is y decreased for every unit y change, right? So like a unit, 1 unit of x changes, right? So x increase. Now what happened to the y? So y will be increased, right? So y will be increased when the slope is positive, right? And now y going to be decreased when the slope is negative. Okay, so now in here, so we said because this is y equal to 0.096x, so the first one is that each year between 1940 and 2010, the average increase in the minimum wage is the 0.096. Okay, so here, we see here, the key things here, let's say each year increase, that's good because I have a positive, is 0.096, okay? So that's why we say, okay, this will be my answer. So now let's take a look at what's wrong with the other one. Okay, so then they said here, each year between the 1940 and the 2000, the average increase is 0.49, right? So 0.49. So this is the number is not right. The 0.49 is the intercept. So intercept, as we talk about how to interpret the slope interception, we said that this is the initial value. So here is the problem for the part B. Okay, so the things here, people get confused, or is what? Is the C's here, right? So they say, hey, every 10 years, right? So because in here they say it's every 10 years between 1940 and 2010. Well, can that be the every 10 years Okay, so this is they try to trick you, see here. So for this province here, the graph, right? So the graph is plotted in every 10 years, right? But in here, take a look, the x-axis here is years, every years, right? So that is not the truth here. So it's not, C is not the correct one. Okay, so then the same way is here, every 10 years, then this is the intercept. So this is not the truth here. So if this is a 10 years, right? So if this is based on the units of x is 10 years, they should write it out in the x-axis here. So, but in here, the x-axis still say the years, all right? Okay. Okay, so now let's take a look at 5.1s here. Okay, so the 5.1s here, they said between the 1985 and the 2003, the data was collected 3 years on the amount of plastic produced annually in the United States in a billion tons. The graph below shows the data in a line of the best fit. The best fit line is here, y equal to the 3.39x plus 46.89, where the x is the number of the years and y is the number of the plastic produced. Okay, so which of the following is the closest percent increase in the billion tons of the plastic produced in the United States here? Okay, so here, these ones here, we need to be careful. So here they say, I want to find the percent increase, right, in the plastic produced. Okay, so my graph show me, right? So my graph show me is the years versus how much, right? So how much plastic. So I want to find the percent of the increase. So let's take a look here, right? So it's from, okay, so this is the number of the years since 1985 here, right? So, okay, so now let's take a look. I want to find in the 3 years, right? So from the 2000 to the 2003, okay? So the 2000 to the 2003. 2000, this is the number since 1885. So 2000, that means I'm looking for the 15 here, correct? Then 2003 is 1, 2, 3, right? So I'm looking for what? It's the 18 here, right? So now I'm going to the 15 is here, 18 is here, all right? So now I can write it. So I know the y is equal to 3.39 times 15 plus 46.89. So what is this one's here? This will give you 97.74. Then for the 2003 is x equal to 18, right? So it's 3.39 times 18 plus 46.89 here. So it will be 107.91. Okay, so the increase from the, increase from the 2000 to 2003 is really is what? Is 107.91 minus 97.74, right? This is the increase. And this is 10.17 tons of plastic. So they also want to find the percent. So your percent, you always start with the initial year. So it's 10.17 over 97.74 here. So you will get a 0.10. Okay, so 405. So it's what? It's very close to what? It's close to 10%, right? So this is the 10%. So this one is a little bit tricky and it's a little bit harder. So you need to read because the key things here is the percent increase, okay, from the 2002 and 2003. So you need to know how to change to the 2002 to 2003. So you need to know how to change this to the years, right? So it's 15 and 18. Then you want to find the percent of the increase. Okay, so now let's take a look at okay. So now this one here is easy. So let's say which of the following is the best interpretations of 3.39? Remember, what is the 3.39 here? 3.39 is what? It's the slope, right? So the slope, that means every unit of the x increase, y will increase or decrease, depends on the positive or negative. So this is a positive, so the y is going to increase. What is the y? It's plastic, right? So let's take a look at what is the each answer. So A, they say the amount of plastic in billion of pounds produced in the United States during the year 1985. No, this is not what the slope definition is here, right? The slope definition, so this one really is the intersect means, so it's not a slope definition. Okay, so then they say it's the number of the year is took the United States to produce 1 billion pounds of the plastic. No, that's not the slope mean. Okay, so number C is here. The average annual plastic production in the billion of the pound in the United States from 1985 to 2003. No, that's the total amount, and this is the slope. So let's see here. So it has to be B. So let's see is true or not. So the average annual, okay, so this is the keyword, right? Is increase in billion pound to produce per year in the United States. Right? So per year, that means every unit of the x increase, y will increase this much, right? So that's why we talk about in the interpret the slope and intercept in the other video. This is very important, right? So we use it. Okay, so now let's take a look. So this is the, the distance from the sun and to the relation of the densities here, right? So the stars, our planets, right? The distance away from the sun and how is the density going. Okay, so now this, we know this is line with what? This is the line with what type of the slope here? This is the line going to have what? It's a negative slope, right? Okay, so let's see here. Okay, so let's say, according to the scatter plot, which of the statements is true about the relationship because between the planet and the planet average distance from the sun and its density. So we know this is negative slope. That means when the distance is further, what happened to my density here? My density is going to be lower, right? So let's see which one. Okay, so let's see here. So let's say the planets that are more distance from the sun tend to have less density. Oh, hey, the part A is correct. That's good. Okay, so now let's see here. Part B, why it's not true? Let's say the planets that are more distance from the sun have a greater density. No, that's wrong. Because if this is the one, you need to have a slope. It's positive, right? Then this will be true, but this is our slope is negative, okay? So then the part C, let's say the density of the planet that is twice as far from the sun as another planet is half of the density of that. That's not true, right? So this is not true, okay? So the distance from a planet to the sun is unrelated to the density. So that is not true. Neither is because we do see the negative of what? We do see the negative correlations, right? See here. Okay. Now let's take a look. Number 6.2, see here, the related problem. So astronomer has discovered a new planet about 1.2 AU from the sun, according to the line of the best fit. Which of the following is the best approximation for the the density? Okay, so that means we need to use this to estimate 1.2, right? So 1.2, so where is 1.2? So here is 1.2. So we use this line. So we use, so it's 1.2 go dong, 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 dong. So here it will be above 4.5 or maybe 4.6 or something. So which one is the closest one? Yes, it's 4.6, right? Because in here you see, this is a 4.5, right? So this one's here is what, 4.75, and this one is a little bit less than 4.75, so it's approximately 4.6. Okay, good job. Okay, let's take a look at the next ones here. Okay, so this one's here is in the scatter plot, is showing the data for 10 charities, and with the baseline of the fit here. And for the charity, the greatest percent of the total expense spent on the program, which is falling close to the differences of the actual percent predicted by the line of the best fit here. Okay, so now let's take a look. Okay, so total income, right? So it's in the millions of dollars. Okay, so the total of income in the million of the dollars here. Okay, so this is 2,000 million, 3,000 millions, right? And this is the percent, this is Y, this is the percent of the total expense, okay, to spend on the amount here. Okay, so now let's take a look at here. So let's say the scatter plot showing this. So for the charity, okay, so now we need to capture the keyword, right? So let's say for the charity with the greatest percent of the total spent on the program. Okay, so greatest, then which one is the closest to the differences of the actual percent and the percent predict? Okay, so now those are the key things you need to highlight and then see, okay, this is, so this is what? Okay, so greatest, right? So which charity is the greatest? Greatest, that means the highest percent, so this is the charity, correct? Okay, so this is the charity, is the greatest percent. And so this charity, so this is the actual, right? So this is the actual. And then my line is predicted. So the line predicted is dun 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 is in here. So this one is the predict by using the lines here. So they want to find the differences between the actual and the predict. Okay, so the actual and the predictor here, right? So the actual here, this is 90 and 95. So probably it's around 92. And then this one's here, predict is 85. So it's 92 minus 85. So it's about the 7. Right? So this province here, the answer is 7th here. Okay, so when we try to do those type of when we try to do those type of word problem, it's better, you highlight the things, the key things we're doing there. Okay, now let's take a look at problem number 8 here. Total protein and the total fat of the 8 different sandwiches here. So here is the scatter plot. Above show the number of the gram for the total protein and the total fat here. The line of the best fit is what is in here. According to the line, which of the following is closest to the predicted increase in the total fat in gram for every increase of 1 gram of the total protein? Ooh, what do they want to try to find? Okay, so they want to see is the total, is the close the predicted increase. The increase is the, is the keyword in the total fat here, right? Because this line, obviously, we know this line is the positive slope, right? Because it's going up. So this is the line going to have a positive slope. So they want to see increased in the total fat for every increase for 1 gram of the total protein. Oh, the protein is really is my axis here, right? So every change of the x, how much change in y? So what I'm looking for by combining these two sentences, basically I'm looking for the slope, right? So that means every change of the increase for the x value, so x is the protein, how much change to the y is the total fat here, right? Okay, so just like we did before, let's try to 2 points is pretty close to the lines. Line is close to coordinates, so we can get a good estimate here. So, well, this one is not bad. Okay, so this point is 10. Then, so this point, right? So I can say this point here is 10. It's a little bit, the line touched here, so maybe 18. Then let's take a look at another one. Oh, this one's here. Okay, so this point is 20 and a little bit above the 30. So I say 32, see here. So remember, right? So when you try to find the slope, what you can do, see here, you choose any 2 points, right? So then here, then I say the slope here, it will be 32 minus 18, then 20 minus 10. So I'm going to have what is 14 over 10. So it's 1.5, 1.4 here, right? So 1.4. So you look for your answers here. So what one is closest to the 1.4 is 1.5, right? Because those value is the one is a kind of a little bit we are guessing, right? So that's why you choose the closest one. So it's 1.5 is the answers here. Okay, let's take a look at number 9 here. So swimming time versus heart rate. Okay, Michael swam the 2,000 yards on each of the 8 days. The scatter plot is showing the swimming time and corresponding the heart rate, right? So swimming time, this will be my what? X. And what is my heart rate here? So this is my Y here, right? Okay, so this is X. Okay, so this is my X, this is my Y here. Okay, so now let's say the line of the best fit is drawn. For the swimming, let's took 34 minutes. And now let's see what we want to find. Let's say if for the 34 minutes swimming, Michael's actual heart rate was about how many beats per minute, right? Less than the rate of the predictor. Oh, so this is a similar problem like we did before, right? So let's take a look. So here, all right, so now in here, let's say 34. 34 is here, right? So 34 is here. So now I go up here. So what is my actual? Actual is this point, correct? Okay, so actual is this point here. So let's see here. This is the actual here. So actually, this is 140. So this is 140 to 150 is have a 5, 1, 2, 3, 4, 5. So each one is 2. So this is 148, right? So actually is 148. Okay, so what is the predictor? The predictor is the one on where is the one on the lines, right? So it's on the lines here. So it's this one, so it's right intersect here. It's on the line. So what is the predictor here? Predictor is what this line touched 150, right? So it's the 150. So you just use the 148 minus 150. So is -2. That means it's less than, right? The rate of the predict. So it's what? So it's 2 minutes less than the rate of the predictor here. Okay, let's take a look at the next ones here. So this one, instead of doing the scatter plot, they give you the numbers here, right? So those type of problem looks scary, but if you look it and read it and highlight the key things here, right? Okay, so now let's say in here, they said, okay, the Townsend related group invest in 5 different properties, and the table show the amount, okay, the amount of purchase price, okay, so purchase price amount in dollars the company paid for each property, and the corresponding monthly rent, okay, monthly rent in dollars, right? So this is how much they can rent in dollars. So company charge for the property for 5 locations. The relation between the monthly rent, right? So monthly rent is R. So the R is really on Y in dollar, and the property purchase price P. So here is they try to trick you in thousands of dollars. Here can be represented by a linear function, which function represents the relations here, right? Okay, so this one's here. So this is where, if people make a mistake, this is where you're going to make a mistake. So this is rent is Y, the P is X here, right? So you want to find out what is the here represented the relations, right? So you want to find the best fit regression line. So the first one's here, what I'm going to do here, I'm going to find the slope, right? So the slope, we say, we take 2 points. I typically like to take the largest one and the smallest one. So to represent the 2 extremes here, I will take these 2. I will take this one, and I will take this one. Okay, so be careful, this is y, right? So this is y, this is x. Okay, so the slope here is y2 minus y1. So it's 365 minus 515 here. Then the x is here. So here we need to be careful. This is very, very careful here. They say this regression line is doing on thousands of dollars. So your x values here will be 450 minus 70 because thousands, that means you don't use this 230, right? So now this one's here, you get the slope is 7.5. Okay, so let's take a look. Do we have a slope with 7.5? Oh, yes. So I know this is the answers here. Okay, so now let's take a look. They said the Townsend realtor purchased the Glenview Street property and received a 40% discount off at the original price. Okay, so this really has nothing to do with the scatter plot anymore, with the original price. And they got actual 20% off at what? At a discount price for purchasing the property in cash. So let's say which one is the best estimate for the original price here, for the original price in the dollars in Glenview Street. Okay, so let's take a look. So they purchased one is pay. The Glenview is which one's here? Glenview is 140. Okay, so this is 140,000. Okay, so the first thing is here, they pay how much to get it? 140,000. But this 140,000 is the, maybe I'll put it on the next ones here. Okay, so here, the same problem here. So it's 140,000. And this 140,000, in fact, this is a 20 after 20% discount. So the 140,000 really is the what? It's only 80% of the price. So you divide that 0.8. So what is here is 175,000. That means the price was supposed to be 175,000, but I received the 20% discount. So that's why I only pay 140,000. But this 175 is another discount here, right? So this is what? This is a 40% discount of the original price. So what's that mean? That means that 135,000, I already got the 40% discount. So the 135,000 is really is how much? It's only 60% of the original price. So I divide by 0.6. So I will get is 291,666.7, right? So it's very close to this number. So that means my original price. So which one is the best closest ones here? This part B is here. So that means my original price is about 291,700. Okay, and because then first I take the 40% discount, right? And then after that 45% discount, we take another 20%. So this is how do we go back to the original price for the certain discount. Okay? Like I said, the part B is really not related to the scatter plot or line of the regressions, but I guess probably just want to test you, you know, how to get the money back, you know, like try to convert it back to the, you know, the original price before the discount and, you know, the before like the both discounts, like 20% and 40% here. Okay, that's it. So this is the unit we talk about how to scatter plot and the linear regression fit. Okay, so remember, right, if they already give you the scatter plot, the linear regression line, that will be easy. So basically they want you to use that line to find the predicted values, all right? So if they do not give you the line, the easiest way to do it is you try to find the 2 points, and then you try to find the slope, and then to see which answer is closest to your lines here. Okay, so those are the problem in the looks very scary on the test because there's a lot of wording and the graph and the table, but you know, just be careful, you know, when you read the problem and you highlight what is the problem I want you to find, right? So you highlight, say, okay, this is a keyword, this is a keyword, and then you'll be fine. The problem sometimes really pretty simple. It's a simple step. It's just you read the problem very carefully, right? All right, that's it. It is so nice to talk to you, and hope this you enjoyed these reviews here, how to do the scatter plot and linear on the linear regression fit. All right, so it's nice to talk to you, and you have nice days here. Okay, so looking forward to talk to you on the next videos here. Okay, bye.